All right, we're going to spend a few minutes talking about the core technology of the internet, which is called TCP/IP, Internetworking. And that's the invention probably from the 60s and 70s. You can trace its roots. But really, it's made popular by Sun Microsystems. And that's why they said in their ads back in the 90s that we're the dot in .com, because their system of dotted IP addresses is the system that eventually became the internet standard, the worldwide standard. So if you think about Sun, maybe you're driven by their campus up in Broomfield, that's really probably their biggest contribution to the internet as we know it today. So I want you to spend, let's figure on 10, maybe 15 minutes. You can probably even watch this video on 2x because I know you guys are really good at doing that. And we're going to talk about how network traffic works because it's going to be relevant down the road when we start trying to build on that and have you launching your own servers and doing things in the cloud. So I'm on to my Mac here, and I've got my web browser up, and you know how it goes. You log in, you go to the web browser, you put in an address, and it goes somewhere and it gets data from somewhere, and that's how the internet works. You put in a request for data and it comes back. Well, how does it really work underneath? So we want to delve into that a little bit more. So the first thing we're going to talk about is a network. So let's not get too complicated here. A network is a collection of computer devices. Now it's phones and things like that as well. Computers, printers, phones, whatever it happens to be. That's all connected together so they can talk to each other. So the simplest network you can probably imagine is your Wi-Fi network that you have at home. So I have my Wi-Fi here. I'm on the SmartNet network. And if I go into my system preferences, I can see all that. Um, Here's my Wi-Fi, SmartNet, and it says here that Wi-Fi is connected to SmartNet and has the IP address 10.0.1.6. So that's the next thing. That is an IP address, 4 digits separated by periods or dots, and that is your computer's identifier on the network. To make an analogy, if you had a whole bunch of computers in a corporate environment, we're all sitting at a call center, we'll say, each person has an extension. So you call in, you ask for extension 101, and you get Janet, the receptionist. That is her extension. This is a very similar situation. So now we have another computer on the network. I've got this Windows virtual machine that I installed the other day. And so if I do ipconfig at the command line, I can see that that computer has an address 10.0.1.32. So you can see that the first 3 digits are the same, and what differs is that this particular one is 32, where my Mac was 6. And it happens to tell you here that your gateway is 10.0.1.1. So you're getting the impression that you can have a network identifier of 4 addresses or four numbers separated by dots, and it's the last one that's changing here. And it so happens that a network that's configured with this type of subnetting structure can have up to 255 different devices on the same network, or more properly, the same subnet. So it's just like if Janet, the receptionist, who's at extension 101, she can call Mark at extension 102, and they can talk back and forth. They're all on the same subnet, so to speak, or maybe at the same floor within a department. All right, so that's your first deliverable here. What is your IP address? Okay, you know how to do that in the Mac under the System Preferences and Network. You know how to do it in Windows using the ipconfig command. You can see that you have a local IP address 10.something.something.something, or maybe yours is the 192.168 format. Those are the 2 most common things. So just make a note of that. Now you know how to do that. You know what is your IP address. And like I said with the telephone analogy, that's like your extension within the building. This network does not go outside the building. It's just the SmartNet Wi-Fi network, just like your home network doesn't really go outside the building until you connect it up to the inner network. And that's what your router does. So in my case, I have a big white router that sits in my den, and it pulls in my Wi-Fi signals, and it sends it out over the CenturyLink cable, the CenturyLink modem to the internet. You maybe have Comcast and you use a cable modem, or maybe your phone does it and it uses Verizon as its connection to the outside. So if you think about the company analogy, you have extension 101, extension 102. You can't dial directly to extension 101 or 102. You have to have what's called in the telephone world a direct inward dial number. So someone dials, let's say 303-325-6000, and then it says, please enter your extension, and you type in 101 or 102 on your phone and you're connected. Well, it's the same thing for TCP IP internet working. You have your private extension, your 10 dot number, or your extension 101, and then you have your public number, which is how people on the outside of your network reach you. So what is that? How do you know what that is? Well, you can go to this link here, whatismyip.org, and it'll let you see. Most of the time it doesn't matter, but it so happens that in this particular case, my modem powered on and CenturyLink gave me the public IP address 71.218.184.27. So when I send a link request to Google, my computer on the 10.0 networks sends it out. My router says, okay, I want to load up Google. And so Google needs to know where to send the information back to. It can't send it back to 10.0.1.6 because that's a private extension. It needs to send it to the outside public number, which is the public IP address 71.218.184.27, right? Okay, so you're getting the idea that there's a private subnet and a public internet. And usually your private subnet corresponds to your local area network, all the things that are inside your building. And then once you leave the building, you have to go over to the internet side of things. And for that, we have to use the device we call a router. So, back in the 1990s, every company in the world that wanted to get on the internet, they had to buy a router. And who sells routers? Well, Cisco Systems sells routers. Now, there's other companies that sell them too, but that's Cisco Systems' bread and butter. They'll sell you a router. It can be a little router. It can be a big router. It costs $200. It can cost $200,000. But that's the business of Cisco Systems. They're the ones that sit there and connect private networks to public networks to other networks. And that's why they became the dominant player there. So between Sun and Cisco, that's how you set up the first round of the internet. We connected all of our corporations together internally inside the building, and then once that was done, they connected to a router, and then the router from company A connected to its internet service provider that connected to company B, and the routers passed traffic back and forth between the two companies. And as far as the people inside knew, they were on the internet, but now we know a little bit better that there's a private versus a public distinction and what a router does. All right, so that was your second deliverable. You needed to write down your public IP address. Now, the last thing we're going to do here, I know it's already been a few minutes, we're going to just go through the process of checking that we can get to a certain place. So, from our web browser, let's suppose we went to Google, right? Well, in this case, it loads perfectly fine. So, no problem. But what if it didn't load? We've had times where you get a strange error and it doesn't load. Well, what do you do to get there? And this is going to be a nice segue into our next video. But what we're going to do is we're going to do what's called ping. Ping is kind of like the most basic form of troubleshooting that you can do. That's how you sit on one device and see if you can get just the minimal type of connectivity to the next device that you want to connect to. So I have my terminal connection here. So I'll clear the screen so it starts fresh. I don't know. Yeah. All right. So who would I want to ping? Well, let's ping Google. All right. So we'll go to ping space www.google.com. And it tells you, oh, look, we sent 64 bytes to Google's public IP address, 172.217.1.196, and it took 5 milliseconds to get there, okay? And we could do another one. We can go to, let's see, what was a good one there? So this is a community college on the East Coast. And so you can see Montgomery College in Maryland, it happens to be. It has the public IP 3.233.124.74, and it takes longer to get there because Maryland is farther away than Google. In the networks world of things, it takes 50 milliseconds, okay? So you can see that this particular connection attempt to montgomery.edu and google.com, those were both successful, but there may be a scenario where you want to go to rockyvista.edu and see what happens. And it turns out that you don't have connectivity in this case to rockyvista.edu because I guess they're probably not responding to ping or they don't have a a host up at that name. I don't know what the reason is. So that's what it looks like when you don't get a connection back. Um, Oftentimes, the other thing you want to do is you want to sit at your computer's Wi-Fi and you want to make sure your cable modem's working. So what I can do there is I know from this screen that my cable modem or Wi-Fi router is, let's see what it is here. The router is at 10.0.1.1. So if I have a connection to 10.0.1.1, that means that my Wi-Fi is essentially working. So if I can get to 10.0.1.1, the connection between here and my den is working. And now for some reason I couldn't get out to the internet to get to Google, I would say, well, that's probably CenturyLink's problem, because it's good at my house, my Wi-Fi is up, but there's no connection from CenturyLink at that point. So basic troubleshooting steps, giving you a feel here for how IP addressing works. There's obviously a lot more you can spend on this, but we are going to run into IP addresses all the time. We may need to use tools like ping, and we want to understand a little bit more about what's going on, inside the black box. So I'm going to stop here. You got 3 easy deliverables: your internal address, your external address, and copy of the results from a ping command. So maybe you want to ping your internal router address, or if you want to ping Google, it doesn't matter. But now you know how to see these basic types of information, and you'll be able to say to yourself, well, my Wi-Fi is working, my computer network is connected, my internet's working, Google's working, I better be seeing something on the web browser. What's wrong here? So I'll stop here. Looks like we managed to not spend too much time on this, but I hope that you got a little bit out of this and have a little bit better sense of how that works. All right, so actually you can stop listening right now, but I might take one little tangent for, we'll say, 1.5 minutes, 2 minutes. So what's the difference between how the internet connects, how the telephone connects, and how the U.S. mail service connects? So we talked about the telephone service a little bit, and you can imagine back on this picture, there's a lady sitting at the telephone central office, and her job is to connect all those things together, right? So she actually plugs wires together, and she makes what you might call a circuit. There's actually electricity flowing down the circuit. In the old days, telephones had a battery that was connected to the end of the wire out in your farm on Nebraska, we'll say, and to make the telephone work, you actually had to have a battery. So no electricity flowing, no noise comes out the end of the telephone speaker, no telephone calls happening. And then the telephone company, they would bill you for as long as your circuit was connected. So you'd have a 60-second phone call or 2-minute phone call, whatever it happened to be. So in that telephone, early telephone, analog telephone, you actually formed pure electrical circuits, and then the data or the voice was transferred over the telephone. Now, that's what you call a circuit switch network. The internetwork using data is not exactly like that. A lot of the same concepts apply, like the PBX that connects the corporate networks from one to another, and how you have the internal extensions versus the external number. So we use those extensions to motivate the discussion, but the internet does not exactly work that way. It has a key distinction. So what happens with the internet is that your telephone call or your video or your email, it's not one continuous circuit that stays up the whole time. Rather, the data is broken up into packets. So you can think of a packet as a little envelope full of data. And in the Postal Service, the envelope full of data travels from, let's say, Denver, my house in Denver, it goes downtown Denver, then it gets on a truck, and then maybe it goes to Omaha, and then it goes to Philadelphia, and then it gets to someplace in Maryland, 2 days later if I choose priority mail. Well, in that sense, the envelope, it's not really aware of how it gets from point A to point B. It could take, Bob's truck, or it could take Mike's truck. It could go through Omaha. It could go through Detroit. As long as it gets there, we're basically happy, right? We don't really care too much. So we call that a packet switch network. And so with the internet, when you open up a Google web page, your data is broken up into lots and lots of little teeny envelopes. And the envelopes get from your computer to Google over the internet, but they don't all necessarily go the same way. Now, over the course of a few seconds' time, most of them probably actually do go over the same wires or the same fiber optic cables. But in the long run, the internet is dynamic, and On Monday, it may go through Omaha and Chicago to get to Maryland, but on Wednesday, it may go through Dallas and Atlanta to get to its destination. So those routes that it takes, those are all set up on the fly, and there's protocols that determine the best way for the envelope full of data to get there, um, either the cheapest or the fastest or whatever criteria you happen to select. So that's the distinction between a circuit switch network, that is like the telephone system, or a packet switch network, that is like the postal service. So the packet switch network has some advantages. It's generally a little bit cheaper. You have choices as far as how things get there. If something like a nuclear weapon explodes in Chicago and takes that route away, the internet will adjust itself and it'll go through a different location. And that's one of the criteria that they had back in the 60s, what it needed to survive a nuclear war. So it's much more versatile. There's lots of different things that can happen, and we trade a little bit of convenience for other things, maybe configuration and so on, to get us to where we are today. So we'll stop here for good. Hope you got something out of all that.